Hello, everyone, and welcome to the lecture for Module 6 on caffeine. This is a one-part lecture. It's briefer than some of the other topics have been, especially because we'll be covering two substances in this module. There's only one lecture for caffeine, and then there's a separate lecture for nicotine. In this lecture, we'll be talking about caffeine absorption and elimination, how it gets in and gets out of the body, the acute and chronic effects of caffeine on the body, and the use and misuse of caffeine according to DSM-5. So caffeine, it gets into the body by ingestion, so swallowing a liquid or eating a food, swallowing medications that have caffeine. So it goes through the gastrointestinal system. And like all drugs or substances that go through the GI tract, absorption happens in the stomach and in the small intestines. It takes about 30 minutes, a half hour to an hour, 30 to 60 minutes for the caffeine to fully absorb into the bloodstream. And about half of the caffeine that's in the blood will be eliminated after 3 hours of ingestion. It's eliminated through the liver and the kidneys, metabolized and broken down in the liver, and then excreted through urine is how caffeine gets out of the body. The amount of caffeine in different substances really varies, and also the amount of each of the substance that we drink varies. So, for example, in a 12-ounce soft drink, there's 30 to 40 milligrams of caffeine. In an 8-ounce cup of tea, there's 30 to 50. In an 8-ounce cup of coffee, there's 80 to 100 milligrams of caffeine. But a standard cup of coffee is 5 ounces, and that's generally around, they still estimate it to be around 100 milligrams of caffeine. The thing is, that's a lot less than most people are drinking in terms of caffeine. So you're drinking, when you go to Starbucks, more likely you're getting a 12-ounce to 24-ounce cup of coffee. And so the caffeine amount in what you're actually consuming is usually a lot more than when you're reading in the textbook that it's like, oh, one cup of coffee has 100 milligrams of caffeine. So that's just an interesting point to consider. Effects on the brain. So caffeine is a stimulant. It has a stimulating effect on the nervous system. Caffeine contains xanthines, which are adenosine antagonists. So they do not allow the signal to transmit at the adenosine receptor sites. And so there's theophylline, which is tea, and theobromine in chocolate. Both of these are types of xanthines, which again are substances that are similar to adenosine, so much that they can block the receptor site of adenosine, but then stops that signal from progressing. So that's the antagonist part. Adenosine is an inhibitory neurotransmitter, so that means it causes a sedation response. And inhibitory means it slows things down. So adenosine in the body is this kind of, they call it the brake pedal. It really regulates and slows down the firing of neurons in the brain. There are adenosine receptors in all throughout the brain and also in the peripheral nervous system, in blood vessels, fat cells, and the heart is sort of all over the body. And adenosine itself is a byproduct of metabolism at the cellular level. So it's produced within cells all over the body. So what's happening here is we get a double negative. So caffeine inhibits an inhibitor, which means that it then stimulates. So inhibitory neurotransmitters, the adenosine going about its business, slowing things down in the brain, and then xanthines come along and they block that up. And they say, adenosine, stop, slow your roll. You can't regulate things anymore. So without that regulation, the nervous system starts to activate intensify and stimulate. And that's how you get the stimulating effect of caffeine on the brain. And so, because of that stimulation, you get acute effects like feeling more alert, having a bit of an increased elevated mood, feeling like an increased performance because you're less sleepy, you're a little bit more vigilant, your motor functioning is working a little better. But also because of that quickness that the nervous system is now operating with, you do see some impairment in decision making. So that ability to regulate and modulate is important for decision making, and caffeine kind of breaks that down. There are it's a mixed bag in terms of the long-term effects of caffeine use. We do know that it has a negative effect on fetuses in pregnant women, especially at a rate higher than 200 milligrams a day. Then you start to see a growth restriction in the developing fetus. There are links with caffeine to high blood pressure, high cholesterol, and also to osteoporosis, or the degeneration of bones. On the flip side, it does seem that caffeine might offer some protection against neurodegenerative diseases like dementia. So again, there's that mixed bag here in terms of the long-term effects of caffeine. Caffeine intoxication is was both included in the DSM-4 and is now in the DSM-5. People call this caffeineism, and it can really resemble a heart attack. So it can be quite scary for someone who's experiencing it. So it's the ingestion of more than 250 milligrams of caffeine, and then experiencing 5 or more of these symptoms here. So restless, nervous, excitement, having difficulty sleep, feeling flushed, diuresis is increased urine output, having an upset stomach, muscle twitching, rambling thoughts, cardiac arrhythmias, feeling like your heart's skipping a beat, feeling like you can't be exhausted, like you're just go, 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 and that like restless psychomotor agitation. Um, it causes distress or impairment in functioning, and it's not due to any other medical condition. So there were some research studies that were pretty popular for a while after um, energy drinks became widely available. And gosh, I'm dating myself, but I lived in a time when before energy drinks were popular, and then once they became popular, there was a lot of research being done about people who were accidentally ingesting too much caffeine because they were just like pounding. Um, they weren't Red Bulls because they weren't as tasty as some of the other energy drinks out there. Gosh, I can't. Mountain Dew made one that a lot of people drank quite a lot of, and then ended up with this kind of experience of caffeineism where they just were feeling um, just really crappy, just like sick to the stomach, couldn't sleep, really twitchy. Their heart rate felt kind of out of control, and they would be meeting the definition of caffeine intoxication at that point. Caffeine withdrawal in the DSM. So withdrawal symptoms, as you know by now, tend to be the opposite of what the intoxicating effect of the substance is. So, with prolonged daily use of caffeine and then stopping caffeine, if a user then experiences 3 or more of these in 24 hours, then they are meeting the definition for withdrawal. And that would be a headache, fatigue, feeling depressed or irritable, difficulty concentrating, or even flu-like symptoms. That would all be accounted for by caffeine withdrawal. The DSM-5 also includes caffeine-induced anxiety disorder, sleep disorder, or any other disorder related to caffeine. So in the DSM-5, there's a neat feature, which is that it accounts for substance-induced disorders. So drinking a ton of caffeine can cause someone to experience anxiety. It can cause someone to experience sleep disturbance. That doesn't mean that that person has anxiety that's similar to someone who sort of develops an anxiety condition without caffeine. They're very, very different. And so the DSM makes a distinction there. Caffeine does have some medical uses, so that stimulation of the nervous system really does increase mental alertness. And so if you have a patient who's really drowsy or groggy or out of it, caffeine can be helpful in helping them become more alert. It can lead to dilation of the arteries, which can blood vessels, which can help with headaches by stimulating more blood flow to the brain. Caffeine can result in an increase in urine production, and that can be helpful if you're trying to move substances out of the body. And then also a particular modified form of caffeine can be a stimulant for helping premature babies breathe better. So caffeine does have medical uses in addition to the sort of more recreational use or the cultural use of caffeine. And that's it for caffeine. Like I said, there's another lecture coming for nicotine for this module.